Okay, let's take a look at activity 1. Now this activity will help you understand the concept of the coefficient of determination. We're going to use the 3 data sets that are in this table throughout this activity. For part A, it says notice that all 3 data sets have the same y values. So if you look here, each data set had the same y values but different x values. So what we want to do is we want to find the standard deviation of the y values and what is the variance of y. So we're going to open this up in StatCrunch. So this data can be opened up in StatCrunch. And then what we're going to do is we can just find the standard deviation and the variance of the YA column. So we're going to go to Stat, Summary Stats, go to Columns. We'll select the first Y because it's all the same. And what we want to do is we want to find the standard deviation and the variance. So let's go ahead and do that. So I'm going to go ahead and copy this. Okay, so we can see what do we get for the standard deviation for the y values. Well, again, I think it's important to make sure that we know how to label this. So we can say that the standard deviation of the y values is 4.1819719. Okay, and then what is the sample variance? Well, the sample variance, okay, for the y values is equal to 7.488889. Okay, so therefore there we have our standard deviation and our variance. Okay, now we want to do is we want to draw a scatter diagram of each data set. So let's take a look at data set A, B, and C. So we're going to graph scatter plot. Okay, we want the X data set A, the Y data set A. Okay, and then we want our points to make sure our points are highlighted. And then let's go ahead and then select compute. Okay, so there is the scatter plot for data set A. So I'm going to go ahead and copy that. Make sure that we can see all 3 of them here. So there's the first one. Okay, and then let's take a look at the scatter plot for data set B. So we're going to go to scatter plot. We have X, which is the B data, and then the Y, B data, and then we're going to go ahead and select compute. And then therefore there is our scatter plot for data set B. Okay, and then let's do the last one, which is data set C. So we're going to go ahead, select scatter plot, select the X values for data set C and the Y values for data set C, and then we're going to go ahead and then graph those. Okay, so now we have data set A, data set B, and then data set C for the scatter plot. Now it says which data set has the explanatory variable X that best explains the variability in Y, and why would you say that? So in data set A, it gives us the best linear situation. So we would look at data set A, and that would give us the best linear situation. As you can see in data set B, it's a little bit more spread out than data set A. And data set B, they're way more spread out than any of those first 2. Okay, now what we want to do is we want to find the least squares regression model between X and Y for each data set and draw the least squares regression line on each scatter diagram. So we'll open up StatCrunch here. Okay, so what we're going to do is for the first 2 right here, we're going to select Stat, and then we're going to go to regression and select simple linear. We're going to go ahead and do the X variable will be the X data set A, Y variable Y data set A. And then we're going to go down here. We know that we wanted a fitted line plot. And then what we want to do is now just select compute. So we're going to see the following. So we have our slope and our y-intercept. Okay, and then we have our graph. So I'm going to go ahead and put our graph in here. So there is our graph. And then we know that the slope and the intercept is the following. So that means that for this equation here, we would say that this equation, y hat for data set A, is equal to the slope, which is 1.299x, and then plus the y-intercept, which we'll say rounded to 3 decimal places of 4.216. Okay, so that gives us that information. Okay. Okay, next, let's go back. All right, now let's go ahead and change our options. So we're going to edit our options. Okay, now we're going to make sure that this says now data set B, and this is Y data set B, and then we're going to select compute. And then we have our slope and our y-intercept. And then let's go ahead and copy our graph. Okay, so here's data set B. And if we take a look at the slope and the y-intercept here, we're going to say that the equation here, or the model, is going to be the slope, which is rounded to 3 decimal places, 1.180x, plus rounded to 3 decimal places, 4.844. And therefore that represents data set B. Okay, and now let's go ahead and do the last one here. So we're going to edit again, and now we're going to have data set C, and select compute. And again, we're going to have our intercept and our slope. And then let's take a look at our graph. So here is our graph for data set C, and then here is our information. So let's go ahead and write that out. So here's data set C, and then that model is y hat, which is equal to the slope rounded to 3 decimal places, 0.437x, and then plus the y-intercept, which is 8.146. And therefore that's going to represent the linear model for that. Okay, so now it says to find the linear correlation coefficient between x and y for each data set. Okay, so let's take a look at data set A. So we want to find, for data set A, we want to find the linear correlation coefficient. So let's go ahead and do that. So if we take a look here, we will see here that the linear correlation coefficient, and let's go ahead and go back to data set A. So data set A, and then select compute. And then if you take a look here, we have our linear correlation coefficient for data set A. And rounding that to 3 decimal places, which is 0.999, is rounded to 1.00. Okay, now let's take a look at data set B. So now we're going to take a look at data set B, and we want to find out what R is. So let's go ahead and change. We're going to edit. Now we got data set B here. Now let's compute. And then let's take a look at the correlation coefficient here. So the linear correlation coefficient for that is 0.973. Okay, and then let's take a look at data set C and what is the linear correlation coefficient for data set C. So coming back in the options, we're going to select edit and I'll change this to data set C. Okay, and then what is the linear correlation coefficient here? Well, round that to 3 decimal places gives us 0.306. So now what we're going to do in part E is we need to fill in the following table. We have data set A, B, and C. We want the coefficient of determination. So we know that for A, we're going to take the value of R. Okay, so what is the value of R? Well, this is 1.00, right? So we know that we're taking the value of R and then we're going to square it. Okay, so that means we're taking this 1.000, okay, and then we're going to square that. Okay, so when we square that, we get 1.000. Okay, so let me go ahead and make a little bit more room here so we can see this entire calculation. Okay, so if we multiply this by 100%, we move the decimal place over 2 decimal places, then we're going to get 100% of the variability in Y is explained by the least squares regression line. Okay, so let's take a look at the next one. Okay, so for data set B, we found the number to be 0.973. So that means we're going to take 0.973 and then we're going to square that. So let's go ahead and do that. If we take 0.973 and then square it, and we get 0.947. So we're going to round that to 3 decimal places. So that's going to give us 0.947. And then rounding and then changing that to a percent means that we're going to say that 94.7% of the variability in Y is explained by the least squares regression line. And then lastly, we're going to take the last R that we found in data set C, which is 0.306. Okay, and then what we're going to do is we're going to go ahead and square that value. So we got 0.306. We're going to square it. And that's going to give us 0.094. So 0.094, so 0.094, and if we change that to a percent by moving the decimal place to the right twice, then we would end up with 9.4% of the variability in Y is explained by the least squares regression line.